Okay, hello everyone. Thank you for joining today's webinar. We will get started here in about a minute just to give everyone in the audience some time to get logged in on Zoom and settled before we get started. While we wait, why don't you all type in the chat and let us know where you are tuning in from for, today's webinar. Wonderful. I'm seeing Charlotte, North Carolina, Brooklyn, Philadelphia, San Diego, Detroit, Toronto, Rhode Island, Massachusetts. Wonderful. It's awesome to see people tuning in from all over the country today. And with that, let's go ahead and get started. Hello, everyone. My name is Sultan Mashriki, and I am the marketing manager here at the Architects newspaper. I'd like to welcome you all to the Historic Window Replication, Aluminum Window in Historic Buildings live webinar, a CE Strong webinar series powered by the Architects newspaper. This webinar is sponsored by Graham Architectural Products. This program is registered with the AIA CES for continuing professional education. Questions related to specific materials, methods, and services will be addressed at the conclusion of this presentation. This webinar is recorded and can be easily replayed when re-registered on the same webinar registration page. Please allow 7 business days to process certificates of participation and AIA credit reporting for this presentation. Please remember that we encourage you to ask questions throughout the presentation using the Zoom Q&A button that's found at the bottom of your Zoom windows. Questions will be addressed at the conclusion of this presentation. Now I'd like to introduce you to today's presenter, Bill Wilder. Bill Wilder is Director of Technical Sales at Graham Architectural Products, bringing over 35 years of experience in the window industry. Since joining Graham in 1986, Bill has held roles in field service, project management, and sales. He specializes in helping architects and preservation teams navigate complex historic window replacement projects, ensuring compliance with preservation standards while meeting modern performance needs. Bill is also a recognized speaker on historic window replication at industry events. Again, please remember to leave your questions for Bill in the Q&A window, and without further ado, I'll hand it off over to Bill Wilder.
All right, thank you. Again, my name is Bill Wilder. I'm with Graham Architectural Products, and today's presentation is on historic window replication. Our learning objectives today are that at the end of this program, you'll be able to, one, have a better understanding of the capabilities of modern aluminum windows in reproducing various historic wood and steel profiles and details. Two, discuss the major design criteria, factors to be considered during the window selection process. Three, identify window details which correctly replicate the historic window components and meet the intent of the project. And four, identify and describe several historic window components and how they can be addressed and detailed correctly on historic replication projects to ensure that the submitted project is compliant to what your needs are and accurately represent what the end product will look like. Again, we call this aluminum windows in historic buildings as a subtitle, and this is kind of a tongue-in-cheek slide that I call the good, the bad, and the ugly. And to many historic purists, this is their perception of an aluminum window in a historic building. Oops. And as you can say, this is a little over the top, and this is kind of an old photograph, but it caught my eye driving down the street, and I had to take this picture because again, this is a perception that we get and we see out in the industry. But the industry has changed. In the last 60 years, aluminum windows have evolved dramatically and improved in performance and how they're able to replicate aesthetics. Aluminum extrusion and castings can be customized at a relatively low cost, depending on the job size and the number of windows. Um, New dies and castings can be per window more of a minimal expense if there's enough windows on the project. Therefore, and they can very accurately or almost reproduce the exact appearance of the original profile they're trying to match. So today's presentation will show A, how aluminum windows have evolved, and then also how you can ensure you get and all the submissions and all the bid proposals that are supplied accurately reflect the intent and the needs of the project. So aluminum. We talked about this in the last slide, that the capabilities of aluminum has changed dramatically. Aluminums can be cast, molded, and milled into many different shapes, mimicking wood, steel, and copper, so forth, or other materials. And if, as you look at this, these pictures that I'm showing, this window right here, the complete window over on the right side, everything inside the masonry is aluminum in there, including these ornate shapes at the top, all the mullions and everything. And if we pivot over here to the photographs at the factory, you'll see the individual window components and how they are manufactured. And again, these were manufactured from a kind of a compilation of cast parts, milled aluminum, and aluminum extrusions that all went together and then were pieced together. They're painted with a factory applied uh, finish that can be warranted for up to 20 years. So you get a high performance finish and the aesthetic that's required to meet whether it's tax credit approval or just the historic intent of the project. And this is a kind of a great photograph showing the capabilities of aluminum in saying replicating steel, but actually these windows weren't replicating anything. This is a connector bridge at the University of Michigan connecting the old historic building to a newly constructed building. The new constructed building was designed to look like the old building. The old building had aluminum windows went into that one and replaced the old steel windows that had lead caming like we show here. And this bridge is about 3 stories up and connects the two buildings, a little walkway between them, and is just sort of ties the whole appearance. But this does a great job of showing what aluminum can do. Again, this one, between the aluminum panels at the top and the bottom, everything is from, other than maybe some structural steel that's hidden, everything is from the aluminum window manufacturer. And you can kind of see the fabrication process over here as these parts are pieced together at the facility and then were applied out in the field. And these capitals and bases are there's are cast aluminum components that were then had a factory applied finish. Again, that same high performance finish as the windows did. And this just does a great job of how, from that first slide I showed to where aluminum, what the current capabilities of aluminum is today in replicating a myriad of shapes. And we'll get into the specifics now of how aluminum can replicate these old shapes. We'll start with steel windows. And one of the most prominent steel windows out there occurs in many of the older manufacturing, warehouse, or industrial buildings, like we're seeing here in the photograph. And it's what the Park Service and certain historic consultants refer to as steel industrial sash window. We in the window business kind of call it the floating vent for kind of obvious reasons. This vent just appears to float in the middle of all these muttons that are all the same shape and profile, kind of matching the profile of the perimeter frame, but they're all narrow and it just floats in the middle. But this is a tricky shape to reproduce. And for years, the Park Service would complain that nobody was reproducing it well. And no, and on a significant building, nothing was acceptable. Here's a significant building. 5,000 of these windows. This is the type of building that will drive innovation, and it did in this case. A little over 10 years ago, the owners came to us and said, we want to replace these. And we showed them the current technology. We built mock-up size windows, but we put them in wood bucks because they weren't allowed to take these windows out. The um, uh, New York City Landmarks Commission said, no, they are artifacts of the building. They can't come out. So they wanted to put mock-ups in bucks. They thought they looked great. The committee came down and said, no, nope, not. That's what we're used to seeing. We see heavy sight lines. It doesn't replicate it well enough. And here you kind of see what they were talking about. These floating vents, and the defining feature of this building was how they alternated up and down. And they did not want to lose that. And nothing out there was acceptable. You couldn't replace them. So but the owners, they tried refurbishing these windows, and it was just way too costly. And when they air and water tested it after they were completely refurbished, it still leaked air and water. And they couldn't even get the pressure up enough to run what would be considered an industry standardized test. Air leaked in so much. And with this being converted from manufacturing or warehousing space to office space, that just, they were losing value to the building. So they asked us, could we design a window? And it had to match. Here you just kind of see the whole concept of the floating vent in there in this old literature in there, and they wanted a reproduction of this. On the left, this was the existing technology. And in fact, this was the original mock-up, just kind of superimposed into a window. And you see the heavy lines running across the top and bottom of the vent. You lose the effect of the floating vent there, and then the smaller grid work around it. The interesting thing happened, what we did was we built 3 windows, sized them that they could fit into a masonry opening on the job, but we put them in a wood frame, took them up there for display, and the owner felt so confident that they would get approved that he asked the installer to put them in, but save every little piece that you take out and don't damage anything just in case they didn't get approved. So they put the windows in. They invited the New York City Landmark Commission to come down, walk across the West Side Highway, because this sits right along the Hudson River, and turn around and pick out the replaced windows. And they couldn't. Actually, you can, because the glass is much smoother and the low E coating creates a slightly different look to the glass. But without that, without a trained eye, you couldn't tell. They came back inside, took a look at it, and said, okay, that's acceptable. And they moved forward. Here's kind of an example of the technology at the time. And unfortunately, this is still prevalent today. And you have to be careful looking at proposed products. But here you see the wide sight line that supports the vent. Well, the picture is not great, but it's getting a little washed out. But there you see wide sight line. It doesn't really look like a floating vent. And this is all applied grid work here. That's applied grid work, but they had to run a true mutton, which is the right thing to do. You don't want that being all one big piece of glass with applied grids, because the grids will bow away from the glass. Expansion, contraction occurs in aluminum, especially if it's dark painted, and it will bow. And some people will counter that by taping them. You don't want to tape the muttons to the glass, just in case you ever have to replace that piece of glass. And tape through expansion, contraction, if it's only taped on over 5, 10, 15 years, it'll start to peel at the end. So typically in commercial windows, we don't tape on exterior grid work for those reasons. We want the windows to be maintainable and stand the test of time, so forth. So this is the problem. Here was the solution and what's available today. But only a few manufacturers that specialize in historic windows do it this way. And there are other ones that have what we just looked at. And that's, like I said, it's still prevalent today. And you have to be careful when you look at submission drawings that they show every detail, because I've seen ones where they just sort of conveniently, oops, we didn't show that detail there. So you want to be careful. And here you see this picture taken at the same elevation on that same building. And here, this one opening right here. And when you compare that opening, this is existing, this is new. It turns out to be a great reproduction of the original windows. So, taking a look at this in detail, some of the key things is this concave profile, which was the most common profile. And these old industrial sash windows were always glazed on the inside. So the putty was on the inside, and the outside tended to have a profile to it. The most common was this concave profile. Sometimes it was kind of a T shape, but more common was the profile. Occasionally it was just flat, but most of those are long gone because they didn't hold up well. They lacked a structural strength. It wasn't just an aesthetic, it was there for uh, structural reasons and durability reasons. But if you see here, the key is the old mutton bar was 7/8. The new one is 1 1/8. And there's a reason why it's 1 1/8. It grows because it had to grow. And the reason is insulated glass. Here you see it's 1 1/8. If you look at this, the old piece of glass overlapped the frame by 1/4 of an inch. However, insulated glass has to overlap the frame by a minimum of 3/8. Some glass manufacturers require a 1/2 inch, but there are ones that will still they only require 3/8 of an inch and give you a warranty. You want a glass warranty on the building. So therefore, you have to manage and stay within the constants in the industry, which is minimum of 3/8. So in essence, you're growing an 1/8 inch at each slate of glass. So you go from 7/8 to 1 1/8. And then at the vent, it grows about the same amount. So that's a result of insulated glass. So, uh, but when you step back and look at, in this case, a 4 foot by 8 foot window, you really don't see the difference. And because you're maintaining the same profiles, the same shape, and the same proportions, it's not really noticeable, and you're getting a high performance product in the end. So, how do you detail this to ensure that you're getting the right product? We always recommend that you show the cut of at the vent and also the supporting mutton bar. So here you see the supporting structural mutton and then the vent in there and then the simulated mutton. This tends to be the cut that some manufacturers will leave out if they don't want to show it because it's an inch and a half or, and maybe even a different profile. Sometimes they'll do this. This will be a trapezoid profile and out, but the grid work that butts into it is concave. So I think the Park Service, I heard them refer to those as a Frankenstein window. It's parts and pieces of everything. It's not one consistent look that you're looking for in your project in there. So by drawing your bid documents this way and then looking for submission drawings for product approval, they should all show all these different cuts. And here again is just kind of a great picture of the resulting product. And if you look at where the shades aren't drawn, like right up here, you really shows the floating vent well, as opposed to that picture of the bad one that's out there. And like I said, it's still prevalent. They get submitted all the time on projects. And again, this is from that same building we just looked at. This is from the shop drawings on that. And there's just a couple of other unique things. Here you see it shows all the details, but there's a couple of unique things that are typical with these steel replacements. One is there's often a steel structural angle up here at the top that the windows were laid up against. So the common practice is you remove that, the existing steel lintels or supporting steel stays in place. And you replicate it with a piece of aluminum that's painted with the same high performance finish as the windows, and you lay the window up against it just like the old windows were. And in this case, sometimes sills can be a challenge because those old steel windows were mortared into that sill. So you're breaking that out and you get a lot of damage, a lot of collateral damage across that sill. And sometimes, and then your point of sealant can be a challenge as well. So in this case, we're able to navigate through that by putting a subsill underneath it, which from a performance standpoint is great because it can capture any water that might come in at the mullion over the years and so forth. So it's kind of ideal. And it also reached out here to get uh, clean masonry for your primary sealant joint at the sill, because that wasn't available like here it is at the jam in there. So it's a great solution. This is a relatively low cost item that you've customized to whatever that resulting condition ends up being, that allows you to put this in a high performance watertight finish that meets the aesthetics. And the Park Service they don't like to see this underneath if that sightline grows too much. And a lot of times the contractor will cut away some of that sill where it's all roughed up. So you're actually dropping the sill, and it allows room for the sill starter. Or, it there can be a need for justification that you need something like this to make the project move forward, and the Park Service will consider that there. This is optimum. Sometimes they don't allow it. And there are cases where there's a lot of vents on these buildings, and when being converted to office space or even residential space, and the interior spaces are conditioned, they don't need the ventilation. And a fixed window will perform better, and there's a cost savings to it. And this just shows you can accurately reproduce this appearance with an applied frame that's actually pinned to the trumans that run across there. And a key here is it's not taped onto the glass. So if you ever have to change that piece of glass, you can, without having to get to the exterior of the building and cut that off, then to be able to pull that piece of glass inward, put the new piece of glass in, and then, oh, by the way, get back up on the outside of the building and put a new one of these on, because the old one probably got damaged, typically gets damaged because that's strong tape that you pull off of there. So typically you don't tape anything onto the exterior glass um, in there. The interior is a different animal. You don't have the expansion contraction that stresses it. And if you're going to put stuff back on afterwards, you're standing in front of it. You're not 8 stories up in the air on a swing stage trying to tape this on. And with that pressure sensitive tape, if you want it to stay on, you have to apply constant pressure over, for several seconds across that. Not so easy when you're hanging off a building. Here's just something from the old Fenestra catalog that kind of just showing how what the old shapes look like, and with that the typical concave shape and so forth, as we typically refer back to these old catalogs when detailing the old windows, what they actually look like, and to create our comparison drawings. Now we're going to pivot. That was the industrial sash used on commercial type buildings and warehouses. What I'm showing here is a residential steel window. So this isn't the floating vent, not the industrial sash. This is a residential application. And in this case, the putty was on the exterior. So these windows were reglazed from the exterior, typically because they're only a couple stories tall. It's a residence, a house. Although sometimes they did go up in the air. You see a lot of them go up in the air, and like in New York City, they were still residential buildings, apartment buildings. It might be 12 to 15 stories tall. And they show these profiles on the exterior. Well, this is basically the same window, but with different profiles. You don't have the concave profile anymore. You have the beveled profile and the trapezoid shape down here that replicates the old putty glazed, exterior glazed windows. And here's just an example of a building. This one was kind of unique in that it's taller. I mentioned that, these residential windows were really designed for 2, 3 stories tall. And the old steel windows, really, they weren't up to the challenge. When you go up in the air like this, where you have higher wind speeds and positive and negative pressures that impact those windows weren't that watertight. And on this particular job, when they applied for a replacement, the Park Service said, no, these windows are in great shape there. But what they didn't know was what was happening. And the owners and the architects brought in facade and masonry consultants that took a look at the job and determined that these walls are deteriorating. And they're deteriorating because the old steel windows can't keep out the water, and the water is getting down into the walls and creating damage. So when that was at that hearing in DC, the Park Service determined, yeah, you're correct. So the main goal is to save the building. And to save the building, we have to replace the windows. So they approved replacement. While they were picky about it, but they approved replacement and saved the buildings. Now we're going to pivot to aluminum replicating steel hung windows. And here we see three very prominent buildings I think most people would recognize: the Chicago Tribune Tower, the Empire State Building, and the Chrysler Building. And so there's a couple of things here that tie these together. They're all built around the same time, that early skyscraper age back through the late 20s and early 30s. And the other thing that ties them together, they all use the same steel double hung window as manufactured by Campbell Metal Windows Company. Right here, you see a close-up picture. This is a job in Philly. These are all, there are hundreds of thousands of these put in all over the country. I'll show pictures for, we've done jobs on the West Coast, St. Louis, Chicago, Atlanta. They're all over. And there's a couple of defining features to this window that you kind of see it here, this pull handle and this raised area around the glass and this little groove running down the true buttons. Kind of the opposite. Here you have an inward groove where on a wood window, it's a profile that sticks outward, a trapezoid profile. And uh, here you see a kind of a close-up. This is from old literature from Campbell. And you see a close-up of this raised profile, and you see the pull-down handle. And the significance of this profile, like I said, it's just like the putty profile that everyone recognizes on a wood window, that's critical to reproducing it. Well, critical to reproducing this look is this raised profile, the pulled handle, and also the perimeter frame shape. And here we see, there's a same picture of the original window. And here you see a replacement window. You see the pull down handle, and you can see, if you look closely, it's not a great photograph, doesn't show up great on the slide, but you see the raised area around that piece of glass. And you'll see the raised area doesn't continue, there's no continuation. It's a true picture frame around that piece of glass. So here we see it in a couple of comparison drawings that really confirm that the product that's being submitted, or if these were in a bid document, that confirm exactly what we're looking for here. And you see the three critical items that are being matched. The raised profile around the glass, that little rectangular shape, there it is on the original window. And over here on the right, you see it on the replacement window. You see it again up here. You see it again up here around there. The pull down handle, it's right here, replicated. And even the perimeter metal frame was always this 1.5 inch dimension from the masonry. The metal portion of it was 1.25 inches, and then there was always like a sealant bead of 1/4 inch, but very consistent on these. And here you can see how it can be replicated in aluminum. One word of caution: if you're looking at a project like this, you should always have demo work done to see if the window frames can be removed without a significant amount of collateral damage to the building. Because those old steel windows were literally mortared into the walls and can be very difficult. And if you're working in occupied space, it may be cost prohibitive, or just do it to completely eliminate that frame. And if that's the case, and it can be proven, the Park Service will allow leaving part of the original frame in place, because it literally can take jackhammers and so forth to take that out. So you have to be careful with it. And here we see a replacement. Now, this is in New York City. The criteria on this job was a little bit different. It wasn't a National Park Service job. It was New York City landmarks, and they valued certain things different. They didn't do the raised profile or the handle, but they were really critical of the overall sight lines and replicating this mullion, which they saw as the real defining feature on this. So they looked at this job maybe a little bit differently than if it was in Philadelphia or Chicago or something. But here you see the window manufacturer, you see these old mullions, and You see how they were replicated. This was actually a compilation of about 9 different extrusions that went together. This little decorative um, picture framed grill work was actually applied at the factory to the flat piece of sheet metal from the backside. It's corner keyed together. So you have really tight joints. All the weather resistant part is back behind that in the mullion. So that was just sort of a water shield out there. So everything performed very well. All the thermal breaks are hidden, hence why this thing took 9 separate pieces of extrusion all kind of snapping together out in the field to come from the factory cut to size. They literally just kind of built them and put them together and then popped in the window. And you see this building's on Fifth Avenue. They're very particular about it. And you kind of see why. If you look at the reflection, there you see the Chrysler building. There's the Empire State Building, very prominent location. They wanted an accurate reproduction of the key features that they deemed of value. And that's always a challenge from a window manufacturer standpoint is what's valued on this particular project as far as the aesthetic and where do we have leeway? And we just work through that process. Sticking with aluminum replicating steel double hung windows, we touch on the what's called the Voigtman window, which in the end was supplied by the same Campbell Metal Window Corporation, but it was a different option off of their steel window. Not nearly as prevalent, but you see it in some significant buildings. And here we see it's the old Farley Post Office in New York, which is now the Moynihan Train Hall. So it's a pretty prominent, well-known building. I travel through there on a somewhat regular basis. And perhaps some people here listening in have traveled through that and walked around that building. And what's key on that building is this profile changes. It's a concave profile on the exterior windows around there. Well, that can be replicated in aluminum without much difficulty. Here, they couldn't really remove the old frames because of all the decorative metalwork around it. And you'll see that on the following picture. So they had to keep the frame in place, but because the sash was so big, they had room to fit them in there and match all these sight lines and do a great reproduction of it. And here you kind of show why. What if you look at the window here on the right, the arrow is pointing to that concave shape. So it shows up well. Here's all this exterior ornamental metal that had to stay in place there. So they couldn't remove the old frames because all of that would come down, and they didn't want to rebuild all of that. And one of the reasons was if you walk around this building, 90% of the windows on the outside are refurbished original windows, but there's a handful of them that had to be replaced. So they were replaced in aluminum. That's a near exact match to the original steel. And if you're on the interior in the courtyard areas, there's several hundred windows that they were all replaced, but with this historically accurate window. Now let's talk about aluminum replicating copper clad windows. And while that sounds difficult, but to be truth, copper clad where they're wrapping over wood, the profiles tended to match and sight lines tended to match old wood hung windows. So if a manufacturer has a window that does a good job of replicating a wood window, it probably can replicate a copper clad window. And the real trick is in the paint. You just have to have a paint it in the color that matches that patinaed copper finish as we show here. Now, there's something a little bit unusual with these windows is this Asbury Park. This sticks out onto the park. I mean, out onto the beach in Asbury Park, kind of a famous location for several reasons. But these are all triple hung windows up there. And you can see that each one has their own plane. Each old of the old wooden sash actually operated. And on this particular one, this particular replacement, all 3 of the aluminum replacement sash do operate. Now, in more recent years, window manufacturers that replicate this we've kind of pivoted to the top 2 sash don't operate. It's a cost and energy efficiency thing because most times people don't need that top sash to operate. They just need the bottom sash to operate in there. Uh, so We were able to replicate it. And again, the key thing is it's really just a paint finish item for the most part. It was a custom painting to match the original brick mold profile was on there, but other than that, uh, other than it being a triple hung, it's a standard window. And here you kind of see another example of what starts with a standard window that looks kind of like a wood window to start, and you paint it to match that copper patina finish. And you have a window that looks historically accurate. Now, on this one, you kind of see there is something different going on here, something unusual. This building had all the windows replaced, but to save money, and this is common, they didn't, they did all these, what's shown here is obviously a curved and plan window. They did them as flat windows, which is kind of the common thing. And because this is at a prominent location in the building, one of the main entrances, they didn't like it. So they came back and said, hey, can you build these as a curved and plan window? And oh, by the way, can they operate? And you're going to have to pass the modern water test that the old windows didn't have to pass. So we kind of went to work uh, and worked with a couple of curving vendors and so forth, coordinated and put them together, took them to the test lab. They passed, and we proceeded with the job, and it came out great. This is not an inexpensive proposition. But in this case, they deemed that it was such a key component to the building that they wanted to go that route. This wasn't a historic issue with local landmarks or the Park Service. This was the owner's decision to go this route. And here we see aluminum replicating aluminum windows, which you're starting to see in the historic market is, yeah, they're old wood windows, old steel windows, but now they're starting to replace aluminum windows. But this was a very early vintage and a kind of a prominent building. This old original Red Cross administration building is right across the street from the executive offices buildings in DC. So prominent. And but what's interesting, these early vintage aluminum windows were actually built like wood windows, and they look like wood windows. And we replaced it with a fixed window that looked like a wood window. The interesting twist to this job was they were doing some demo work and while doing the shop drawings, and they pulled one of these two-story windows out to take a look at how they're going to anchorage it. And they discovered that the exterior of these windows were all kind of a bronze color. But when they got underneath the masonry where it was protected, it was mill finished aluminum. So right away, they took this to the architect, said, what do we do? Who took it to the local historic entities that were the decision makers and say, what do you want to do? These were aluminum, but it's oxidized over the years through acid rain and so forth that now it's a bronze finish. Do we want to go back to the original look, or do we go back to what people know recently? And they decided on this job to go back to the original look. So they went to a clear anodized finish, which now puts a protective coating on that will protect it from oxidizing like that in the future. That was not available at that time in there. So we're able to recreate the look after a little bit of a hiccup. And these are kind of things that you run in through the process on these historic jobs. There's almost always something that pops up. Now, we talk about aluminum replicating wood windows, and here's another specialty item. This is the London House Hotel in Chicago. It sits at a very prominent location. You see right across there's the Chicago Tribune building, and right next to that, hidden by the wall, is the Wrigley building, and the Chicago River runs right in front of it. Actually, this picture, I think you're looking from across, or maybe you're taken from the bridge that crosses it. So a very high profile location. But the challenge here was most of these were an aluminum hung window replicating old wood hung windows, but 50 of them had to be ADA accessible, which was a challenge for a hung window. You could put cable systems around it, but they didn't want to go that route in a hotel. So here was the solution. As you see, there's a handle down here at the bottom. This is actually an in-swing awning. It's not a hopper that would open from the top, open up here. If you put the handle up here, it's up too high out of reach and wouldn't be ADA compliant. So I had to put it down here. This will swing open from the bottom, a little bit different than what you typically see, but it met the criteria in limited opening, so it didn't even come in much past the interior stool here, and we're able to meet that look. And if you stand outside the building, you can't pick out those 50 windows that just are sort of scattered throughout the building. And you see the exterior profiles. This thing looks like a hung window right down to the sash lug. I'll touch on those sash lugs in a minute here. Another case of aluminum replicating wood window is these are old wood casement windows at um, Yonkers City Hall, the old historic building. And you can see they were replicated. This is the new aluminum window over here, replicating the kind of the ornate grid work and curvature in there. They actually went to a tilt and turn window because you could just tilt it in from the inside and get ventilation out the top, or you could open it like a casement window in case you had to get out to clean it or whatever. Something kind of unique about these windows is at the interior of a couple of the courtrooms. They deemed these interiors to be significant and they want to take them back to their original look. And the reason was they were kind of famous because they were the where the courtroom scenes in the movie My Cousin Vinny were filmed. So they wanted to maintain these because they were getting a lot of tourist attraction at that time. So they wanted to keep this look and match all this existing woodwork on the interior. So they wanted a window that would match the original. It was a natural wood grain finish on the inside. Well, this is aluminum done, and we use it typically on historic jobs. You don't need this ornate profile on the inside. You just need a flat bar showing it. So from the outside, it looks like a true divided light, but now they want to look like this on the inside, create a profile. And this is a paint finish. This is a two-part paint finish where the base paint is put on. That's the reddish brown color, the base color of the wood. And then there's an applique put on that's baked on that simulates the wood grain. And it's available in many different finishes. There's a cost to it, and it works better in some applications than like on a hung window. We have a lot of parts and pieces and glazy beads coming together. It kind of loses it. All that joinery with the wood grains doesn't work as well. But on a window like this or a fixed window casements, it works out great in here as it did on this project. Now we get into aluminum replicating wood hung windows. This is an interesting photograph. The Milton Hershey Alumni Hall, they were very concerned about the accuracy and how the look of these windows were going to reproduce. So they asked window manufacturers to put in samples. So here is a sample that was ultimately approved. And the reality of this, there's two different types of windows here. This one is a true divided light where the mutton bars are an exact match to this, and these are true divided lights. And this one is all one piece of glass, and this is all simulated true divided lights. And there is a reason why we offered this up as a voluntary alternate in there, because all these little true divided lights, while the center of glass performs well, but it only performs well in that small center area. The perimeter doesn't perform as well from thermal efficiency, and neither do the mutton bars. But the real challenge here is insulated glass manufacturers charge you for a minimum square footage. Typically it's 5. The best you can get is 3. This is about an inch or 1.5 square feet. So if you're buying 3 square feet of glass, paying for 3 square feet, you're paying for double the amount of glass that you're actually using. So they decided, hey, this one looks great. And we get better thermal efficiency and all one piece of glass. So that's why you see simulated divided lights versus true divided lights in the industry. So talking about wood windows, let's just talk about nomenclature or names. I mentioned brick molds already. That's this part out here that goes around the head and the jambs right up against the brick. There's a little rectangular stop bead that gets mimicked. Typically, it gets mimicked with a panning shape. Here's the mutton, that true mutton. You see it's a trapezoid shape on most wood windows. And the other thing that we'll talk about here is this little component right here, the sash lug. We'll get to that in a couple slides. So here's from those same mock-ups, you see it's an exact reproduction of the existing brick mold, right down to every little shape, profile, and dimension in there. This one, of course, the finish on this is nice and clean. Here it's hard to tell, many layers of paint and caulk and so forth, but it went back to the original. Um, what was done here is this was the typical way of installing. We leave the old frame in place and they call this jumping over top of it. It's economical. It doesn't disturb the interior finish, but it doesn't work for historic because of this big increase in sightline. So it was done on this project and is typically done and typically expected unless you can prove that you can't remove the interior frames. It's cost prohibitive or whatever. Um, this the original window frame is removed. And therefore, you put the new window frame. And if you look at these profiles and the dimensions, almost identical. The profile's a little different out here. One, the double hung aluminum window looks a little different. You get this little step out here in the sash. And then because there's insulated glass, you don't have as much room for as deep of a bevel right there. And that's kind of a sticking point with the Park Service. They want to see that bevel as deep as possible, but it's a little bit of a challenge. So the window manufacturers that specialize in historic windows, not all of them do, but have tried to increase this, be as historically accurate. But more recently, the industry has pivoted away from aluminum double hung windows in this case to single hung windows. But it used to be the Park Service would never accept a single hung window replicating wood windows. And here's why. This is a kind of a typical design, and it's actually an older design of a single hung window. And this is at the top. This is the top sash. And here it looks great. That looks like the wood sash. There's your stop bead and brick mold. But you pivot over to at the bottom sash, and this doesn't look anything like what the wood window lid, because this window frame covered up the bottom sash and what should be exposed. And that was done for economics in there. These windows weren't, single hungs weren't really designed to be historically accurate. But about 10, actually on that 360 North Michigan job that overlooked the Chicago River, uh, a new single hung was designed for that job that did accurately reproduce it. And that's the window here on the right. And you see, here's the old technology, here's the new technology. Unfortunately, there's still some of these prevalent that try to get approved on historic jobs. So you always have to ask for a cut at that bottom sash. So you see what we kind of call the sash reveal of that bottom sash, that you see it and it looks like a wood window. Here we see a great example. This job was done at the same time as that. And actually, the submission drawings were done before the new product was designed, but it got held up a little bit. And I received a call from John Sandor at the Park Service one night saying, Bill, we know you have this new window. We're going to reject this window because it's the old technology unless you can get me drawings. And within 24 hours, we had new drawings and it got approved on this. And you see why. Here is this single hung window, and you can see the old sash down below. This job had some other challenges to it. One, these windows were over 10 feet tall. Two, they had to meet hurricane impact at the corner zones of up to 80 PSF. So they had to be structurally strong enough to maintain that 10 feet tall and be historically accurate. And that can be done. And here you see kind of these, well, this is before it was clean, but you see the top sash and you can see the bottom sash. The meeting rail goes the whole way across. Better replicating the look of that wood window. And finally, we turn to one of the last items is these sash horns or sash lugs that we see on a lot of wood windows. And here's this drawing. We showed this drawing earlier, but that the sash lug is actually a continuation of that style where and it's done for practical reasons, not aesthetics. They wanted that to continue longer to reinforce this joint. This mortise and tendon joint could split real easy right here. So they ran them long for structural strength, but it's often done incorrectly. You see, it's a continuation of that rail there. Here's a picture of one where they're done incorrectly. That's not a continuation of rail. It's out, overlapping over the top, and it's just sheet metal. There's no depth to it. So And here's just how it shows up differently. This is old technology, single hung windows. There's no room for it. You would have to put it out in the glass. Here's it's done correctly. Here's an example of them done correctly. And if you look at this, this appears to be a continuation on the new window. This picture is probably 25 years old. So this isn't anything new that it can be done correctly, but what's not new is that people still do them incorrectly. And so how do you ensure that you get them correctly? In your bid documents and in submission drawings, it can be shown accurately. You want to show a straight on elevation drawing and a cross-section cut looking down the meeting rail that'll show the depth of it. Here it's kind of colorized to show it, but here's how it would show up on a set of bid documents. It's like this, where you show it in this cross-section. We show the depth, we show the position relative to the edge of glass. And then finally, when is a curved window not a curved window? Well, you're looking at what appears to be curved windows, but they're not curved windows. Here's the appearance on the inside. And you see, it's actually a square window frame blanked off. This is an original wood window. And this is how you reproduce it. It was done, there's a practical reason. It allows that bottom sash to go the whole way up to improve ventilation, and it's less costly. So that's how they were typically done. Not always. There are true curves out there, but probably 90% of them you see driving down the street are exactly this. And here's an example of this from a project in Pittsburgh, where that's showing these are the new windows. Here you're seeing there's the old wood blank off on the existing windows, but take a look right through there. That's an example of them done incorrectly. Here's a close-up. They didn't reproduce, they got the panning going around, but you can tell that's a square window. They didn't continue the effect, the visual effect of the sash curving around there. And this is common. So you have to make sure you don't get this. And here's it done correctly. Kind of a prominent building that you might recognize, the colors here, and the fact that it's a St. Louis brewery. But here you see the sash rail does follow a track around it. There's the brick mold, but you see the square frame. It's in there, and that's the square sash. But here, when you look at it in the building, they look like they're true curves. So how do you ensure you get them? You don't show a cut right here because that looks like it does at a straight jam. That looks like, everywhere. You show this cut at the corner. See, at that high point, this looks like regular panning. There's your frame. Window doesn't look anything special. But you go to that quarter point, you see the window frame continue straight across the head frame, but this brick mold and what mimics the sash track down along the arch and can complete the illusion that this is a curved window. And on the interior, there's blank off metal on the interior, so you're not looking at the back side of that. And here's just an example of the Chicago Tribune. These were metal windows, but the same effect. Square window on the inside, blanked off, and on the outside, a curved window. And it's just a matter of detailing and how it's detailed and how it's presented to ensure you get the product you're looking for and that meets the intent of the project. So that concludes our presentation, and thank you very much. And I'll stick around. I think I ran over a little bit. I apologize, but I'll stick around for whatever questions you may have, or feel free to contact me at a later date. Thank you.
Wonderful. Thank you so much for that, Bill. That was really interesting to see, and I see a few comments here in the chat where people recognize some of the projects, which is always great to see. And with that, if anyone does have questions, we're going to go ahead and get into the Q&A session now. So please go ahead and drop those in the Q&A button found at the bottom of your Zoom windows. And with that, let's get ahead and started, Bill. First question from Jonathan I'm seeing here in the Q&A. Many of these historic steel industrial sash pivot from the center. Can this be replicated in aluminum?
It's it, it used to be replicated, but the industry got away from it because they simply don't perform. Because you're transitioning your primary seal from the part that projects out and the part projects inward. Those old ones in factories and warehouses weren't concerned about water, but the new windows have to meet current standards. So therefore, both the historic entities have accepted that you just go to an outswing awning on those, and it'll meet the criteria as long as it meets the aesthetic criteria. So those old Center pivot windows, whether vertically or horizontally, have basically gone away because they simply don't perform.
Wonderful. Um, Question from chat here. Are the 1 1/8 sightline true muttons of the aluminum steel replica slash floating vent window thermally broken?
They are, and um, you don't see it in profile, and some of our competitors will pick at that a little bit. There's a thermal strategy to that product. Well, it's not the best case, but it's kind of a compromise to meeting the intent, the historic intent. But there is a thermal separator on the inboard side. But the other part of that strategy is that there's very little exposed metal on the exterior. If you think back to like a radiator and old machinery and so forth, you had a lot of exposed metal on the outside that would draw the heat outward. But the opposite of that is very little metal on the exterior. So you have very little profile exposed on the exterior. So you're drawing less heat outward in there. So there's a strategy to it that allows it to perform well. Now, I wouldn't recommend putting those operable windows up in Maine or up in Canada somewhere. You might have to pivot something that is a little bit bigger in a sight line. But what we find with some of the older products in there, well, they shoehorn in a little thermal break that helps some, but you have more exposed metal in the exterior. So the net effect isn't that great. So it's there are some compromises in place, and we actually offer a higher performing window that has bigger sight lines for those colder climates where they just simply need something that performs better or the codes are requiring it. And that's one of the reasons you'll often see, particularly around the operable vents, you lose more. At those muttons, those perform actually pretty well.
Wonderful. A question here from Stephen asking, recalling Trinity in DC, are shapes available separate from the whole window? Sometimes need brick mold only.
So meaning they're leaving the old windows in place and just replicating a brick mold, replacing brick mold. I mean, the brick mold is a separate component. And sometimes we apply that as a post-applied component after the windows are installed. So that can be an independent component to it. Typically, it's part of a panning system that's applied first. It's all factory back sealed, and then the window goes into that and is sealed, with hidden seals behind that. But it can go in on after the fact, or even go on to an existing product.
Great. And yes, he said yes, custom shapes.
Oh yeah, custom shapes. It's depending on the size, the custom shapes, there can be a cost to it. But if you have hundreds and hundreds of windows, not that, but you'll often find both we and other manufacturers specialize in this, through doing projects over the years, have many shapes in their inventory. And we probably show 80 different shapes on our website. So do some of our competitors. Well, you may be able to find one that is close enough. If it's close in profile and the masonry to glass is pretty much the same, it's often considered acceptable by local historic reviewers or the Park Service.
Great. A question from Harold here. The steel double hung, parentheses, or other type of windows like calamine are sometimes lot line fire rated windows. Would the aluminum windows meet a fire rating?
No, aluminum windows do not meet a fire rating in there. There are a couple of steel windows that kind of replicate it. Sometimes, a lot of times you get leeway because that's often like an alleyway that those lot line windows or fire rated windows are located at, or the building has an interior fire extinguishing system or something that they no longer need to be fire rated in there. We can replicate old fire rated windows, but if they need to be fire rated windows, that can't be done with aluminum in there. You have to go to a steel product. And like I said, there are a couple that manufacture specifically for that purposes. But more often than not, we see that them being fire rated is not a requirement. But if it is, there are steel manufacturers that do it.
Great. A question here from Jessica. When you simulate the divided tile, what material is the tubular profile shown inside the double glaze?
That's very thin. Typically, it's thin aluminum. Some people do that with a like a polyurethane or a polyamide type shape. And it's designed so if you notice, it's not quite the full depth, so it's not touching inside or outside. It's just kind of sitting in that captured air or gas space.
Great. A question from Hans. Curious to hear about your experience with vacuum insulated glass units on historic projects, both as replacements for single pane in the sash and VIG as interior storm window barriers.
That's a tricky question. It's a fantastic product, but there's cost issues involved. And if you're putting it in replacement, and it can be absolutely the correct thing for certain old steel true divided light projects. But the challenges can be cost. But if you're restoring the old steel, it's a great solution to improve the thermal performance. And there are times where, and I've recommended those windows should be maintained. But if it's going to be occupied living space, that may not be the best solution because you still get the problem is you have in those old steel windows, they're still going to leak air and water. Now, if they're fixed windows, not that big of an issue. But that cost issue and the perimeter edge does not perform as well as the in-center vacuum. So you lose some of that performance if they're on small lights. So maybe you don't quite gain back what you anticipate. But if they're larger lights, it's all a matter of cost versus return. And that's something that has to be analyzed by the owner and the people looking at reviewing it. But we've looked at that product over the years as a means of doing that, along with there's new products out there that the Park Service just may not isn't quite up to speed yet with some of the triple pane or thin triples that are out there and hasn't completely analyzed are they acceptable and how are we going to handle that mutton and glass on those particular products. But they're getting caught up on that. And we kind of wait to see where they finally rule on what they will and won't accept.
Great. Question from Brian asking, section details do not indicate a thermal break in the true buttons. Can you comment on the performance of the windows without this feature?
What he's looking at, that's on that SR67 that simulates, that's a steel replication window. And there actually is one in there. It's very well concealed. Uh, Kind of our own strategy. We don't necessarily like to show it off to our competitors, but I already described the overall strategy of that product with you have large exposed area on the inside, but very little exposed surface area on the outside. Like I said, it's the reverse of those old radiator systems or cooling systems that have all those fins, or like the air conditioning system, have all those cooling fins on the exterior that's drawing all the heat out. Well, here we were doing the opposite. We minimize the exposed surface on the exterior. When you go to a bigger sight line out there, you're drawing more heat out in there. So you go to a bigger sight line, but you put in a teeny tiny thermal break, you're thinking, okay, that's a nice little compromise, but you're not gaining much there. Now, we do have another product that has a bigger sight line, but a great big deep thermal break that really upgrades the thermal performance, but you lose something in the historic accuracy. And we see this if you're up in Maine, all kind of across the upper tier up in Canada. Yeah, there's a challenge. And especially these operable windows like this and these little things, they just don't work up there and be code compliant. Thank
Wonderful.
you.
Thank you. Well, unfortunately, Bill, it looks like we've come up on time. It was really great to hear all of your expertise on this topic. Is there anything else you'd like to say before we end for the day?
Oh, I don't think so. I just thank everybody for the opportunity. And if anybody has any follow-up questions or want to send out an email, I think there's some information provided that they can contact me through you or through, the OBE system, and we'd be more than happy. And I've already heard gotten emails from some of the participants in there with have some follow-up questions or even to look at projects around the country. And we welcome that and any question for that matter. So, but thank you very much for the opportunity.
Wonderful. Thank you so much, Bill. It was great having you. Okay, and I just want to give another special thank you to everyone who attended this live webinar. Again, this was Historic Window Replication, Aluminum Windows in Historic Buildings, a CE Strong webinar series powered by the Architects newspaper. This presentation was sponsored by Graham Architectural Products. This webinar is being recorded and can be easily replayed using the same webinar registration link. Please allow 7 business days to process certificates of participation and AI8 credit reporting for this presentation. Another big thank you again to our presenter Bill Wilder and to Graham Architectural Products for sponsoring this webinar. We hope to see you all at a future event. Have a great day. Thank you all so much.